And we move on now to the next interfaculty master program, environmental engineering master. And this is also a rather special case because we have a bachelor curriculum for environmental engineering as well. This would be the direct entrance into this master curriculum, but students who finish the bachelor in technical chemistry are also allowed to enter the environmental engineering master. And our speaker in this regard is Heidemarie Schaar. She is a senior scientist in the Department of Water Quality Management and she is Vice Dean for Environmental Engineering. And she will now tell you all the details regarding this interfaculty master program. Please, the floor is yours.
Thanks, Peter, for the nice introduction. So you saved some time, since I'm often tempted. I think it's switched on, right? Because it sounds like already everywhere. Okay, so welcome. I start with my usual, not advertisement, I start with my usual question. Anybody of you already thinking, environmental engineering could be something interesting? Oh, wow, this is kind of quite motivating this time, because usually there is a no, and then I'm kind of, okay. But anyway, I'm supposed to inform you here, and I'm not supposed to do any advertising. Okay, so as Peter already said, it's an interfaculty studies program, and it's also interdisciplinary, which usually goes hand in hand and can be also interdisciplinary within one faculty. But just to mention it again, so there were 3 major faculties involved in the development of these studies. And it's not a historical point of view, so this it's quite a young program, the bachelor. This is actually for the bachelor one. And it started in 2019. And 2 years afterwards, we started with the master program. So it is this faculty of technical chemistry, then it's the civil and environmental engineering, and it's mathematics and geoinformation. In this case, it's mostly the geoinformation. And you will understand in a minute why it's hard to show that specifically for the master. So that's why I put the bachelor here, so you know where the people got the basics from. So this is now again to wake you up. I hope you're still fresh in your mind. I don't want to go in detail here on the specialization, just to mention or to ask you again, who knows someone studying environmental engineering, maybe in the bachelor? Okay, yeah. So you might know, depending on the personality of them, some are kind of, we know everything, and some are kind of everything and nothing. And this is why during the masters, then finally, you have to specialize. So we have 4 specialization modules, and mostly, more or less, it's not 100% clean, but one faculty kind of deals with, or how to say, one is giving most of the lectures within one of these modules. So one is environmental risks specified on water, focused on water. Then there is another one of these modules, which is now from the Faculty of Technical Chemistry. Mostly it's on air quality and climate. Then we have another water, wastewater focused module, which is the resource management and sanitary engineering. And finally, the probably most exotic one is the one on geodata, on the acquisition and processing of the geodata. I come to the contents in a minute, but just to start with the structure as well. Now it's top down, even though like the basis is on top. So there is some compulsory fundamentals which are crucial that everybody of that all the students have them, because they give you again some sort of idea of the specific modules. So there would be something like Introduction to Earth Observation. Then there is resource management. There is environmental and economic assessment. And there is something like environmental ethics as well. So there we said it's important that everyone knows it, and especially for those coming from different bachelor program, for them it's kind of the entry path, because our bachelor students, they got to know, not intensely, but they got to know the 4 focus areas just to have an idea and a basis for selection. But for you, it would be something like, okay, I get to know this and that module, and so I can have at least a faint idea where I might specialize. And again, in order to avoid a Gemischtwarenhandel, some grocery store where you get everything, you really have to focus on 2 out of these 4 modules. Otherwise, it's just more of the same. I mentioned the general, very general education during the bachelor, but now during the master's, you really have to focus. And in order to really become a nerd, if you want to be one, you can focus. Within these electives, we can focus on, I want to have more of resource management. I want to have more of air quality and climate. So there is this possibility to have the nerd factor or to be broad as well. So that's the possibility for electives, which can be hard and nice as well, right? So let me now quickly go, not into detail, but give you a rough idea on these modules. So if I start on the one on the environmental risks with this focus and the specific focus here on lectures from the Faculty of Technical Chemistry, you have both the monitoring and control of air pollution, and then there is more sort of what you can specialize as well, studying environmental chemistry. You can study or focus on the environmental technology. There is a module, if I remember right. So there is this exhaust gas purification, but think of the monitoring and the control. There you need the environmental technology or techniques as well. So it's always interactive. And one example, it's just here a picture of the Sonnenblick area I got from Anne Kaspar Giebel, where you just have the air quality measurement and then look at the different emissions, how they evolve over the time. And this is then needed to have some either monitoring concepts or control concepts, or to figure out what to do, when, and why. And if we go to the water focus, I mean, this is something like pictures we see every year now, right? And even in Austria, it's not something that is like, okay, somewhere else. And this module, it focuses on the water management strategies, but then also on modeling and on just some early warning and forecasting systems. And here, it's both the risks can be on the quantitative aspect, as you see it here, and what could I do? Here it's like you won't work on that, I don't know what the mobile Schutzwand is called in English, sorry for that, but there you won't do that on your own, but then again you will work with civil engineers who will take care of that. So it's really this interdisciplinary, and cooperation is also part of this studies. And next to the quantitative aspects, there's also the qualitative one, which is really important. So what about water pollution, both surface water and also the groundwater, like our hidden resource, right? So our drinking water comes more and more from groundwater as well. And this is now so I come from the Institute of Water Quality and Resource Management, and our institute is mostly involved here, but it's also the recycling part done from process engineering and technical chemistry faculty here. So there was the shift in paradigm. So first it was about disposing, getting rid of the shit, right? Sorry for that, but it's the way it was, thinking of wastewater at least. And now it's more like, okay, how can we recover resources? Because there's so many resources that are there. It might not have been the most economic strategy so far, but at some point you reach some point where you do have to recover resources also from a resource that hasn't been considered a resource so far. And here's some pictures of resource recovery from phosphorus, some struvite crystals. This is a shot of the Vienna wastewater treatment plants, and this is not a pipe system that is about the diversity pipe system. Don't misunderstand me, I don't want to make jokes, but I like this really a lot till I found out it's about water resource. So if there is water resource pipes, in order to realize it's not drinking water, then they are kind of pinkish violet. Both, obviously, I thought it was now Spanish, but this is in Australia, for example. So water reuse is not common, or it's actually, Austria opted out, so it's not common here in Austria, but I think it is definitely a resource that shouldn't be wasted either. And now the fourth one, which is thinking of geodata acquisition and processing, could be everything, but it's really focusing on environmental data. And as I wrote it here, so it's about understanding the changes, the climate changes, interactions between environment and climate. And then there's also the interaction between the different disciplines and the different modules or focus modules. If you see here this 3D cloud, where you just model the topography, for example, which could then be interesting for flood risk management again, or to find out what could be an area that could be flooded. Or here it's, again, water related. It's about really the soil moisture. So just with some airborne laser scanning, you can find out about the soil moisture, or you go for some geophysical methods, for example. So it's these ways how the different modules can be or can interact again. So it's actually very much focused on the environmental aspect. Good. So if I study technical chemistry, what do I miss to start environmental engineering? So you got this faint idea now about the basics and about the content. So one, you didn't have, I guess, I dare to say you didn't have anything on geoinformation in your bachelor studies. So there's something you definitely have to do. And then for wastewater treatment, for example, we say it's important, it's so interdisciplinary. You will anyway find your strength and learn from each other and help our civil and environmental engineers with technical chemistry. I have a colleague from technical chemistry, and he helps me a lot since I'm not a chemical or chemistry nerd. But then for this other environmental risks module, for the water-focused one, you have to know some basics in hydraulics and engineering hydrology. Okay, this is, I heard that actually these occupational fields, they are quite disturbing and not so interesting. So I will skip that. I think you get the slides if you want to know it. And let me just finish, since I'm supposed to finish now, more or less. Ooh. Ooh. I'm learning. But let me just mention this again. So I hope that I would have some time for this graph, because it's not just about having this module and that module and that and that. It's about having the different disciplines and the different areas which are part of every module. So it's about, for measurement and technology and for data acquisition, you have to know how to deal with a lot of data if you look at air pollution. And if you just have some sensors, I mean, it's not that you're writing down every now couple of data. It's now really about logging lots of data. So big data, we have data science, but we also have to know how to take care or cope with this amount of data. So that's why there is definitely also this modeling issue part of it. And same measurement, you need data if you want to do risk mitigation strategies, for example, or risk assessment. You need that. You need to have an idea also of toxicology and of chemistry, for example. What data do I look at? And then there is something like the techniques, okay, nice, environmental techniques or environmental technology. this is something everybody thinks of. Environmental engineering, environmental technology. Yes, it's an inherent part of it, but there is more. And that's what I try to explain and still try to explain. So what is about the system design? If I think I mentioned the different forms of recovery, or not the different forms, the motivations for recovery, for resource recovery. Phosphorus as this example again. A critical resource, it hasn't been an economic way or approach to recover it, but now thinking of the different system designs we have and considering economy, considering law, that's sometimes our basis, because we know if we want to protect the environment, this would be a perfect solution, but it's too costly, there is no legal basics and so on. So that's why this is all part of the environmental engineering studies. And since we are often asked, okay, you're at the technical chemistry, it's just about technology. And I say, no, we also need these fundamentals in chemistry, in physics, or in natural sciences in order to be able to understand and to model the environmental processes. So thank you for your attention. I hope I gave you a basic overview. Feel free to contact me or contact the Dean's office if you have further questions, and have fun during the rest of the day. I think it's a very interesting program and is a very special day for you. Thank you.
So thank you very much, Heidi, for your presentation about environmental engineering, a master's program, and also for staying within your time frame this time.